Okay, so here's the boring part, functional groups. It is boring, but it's actually super important. So if you think about how many organic compounds in theory you could draw, the options are limitless. You could literally draw an infinite number of organic compounds with varying number of carbon atoms, how they're substituted on one another, whether or not there's a nitrogen, whether there's pi bonds, whether there's rings, literally an infinite number of compounds that you could draw. So to take infinity and narrow it down to something where we can actually group different kinds of compounds together, that's really useful because compounds that have a certain functional group tend to undergo the same kinds of reactions. So I could take, for example, this first functional group of an alcohol and say among the infinite number of alcohols you could have, they are all likely to be able to undergo this reaction and that reaction and this reaction. So it's an extremely useful way to categorize things to be able to understand how they react. And then you'll see that's how the rest of the book is organized when we get to reactions. Each chapter will be alcohols, and then it'll be carbonyls, and then it'll be amines. So they're all separated into chapters because the functional groups react similar to one another. So this R group is meant to signify a generic organic or carbon-containing unit. It could be anything. So if you have a carbon bonded to an OH group, this is an alcohol. Carbon bonded to a nitrogen is an amine. There is sort of a more general, I wouldn't call it a functional group per se, but we call just generally a carbon-oxygen double bond a carbonyl. I know it's tempting to say carbonyl, but it's carbonyl. Not that I'll judge you if you say it differently, maybe in my head. So the reason I say a carbonyl in and of itself isn't technically a functional group is there are lots of different carbonyl-containing functional groups that have full names. So when you have a carbonyl bonded to a carbon group on one side, hydrogen on the other, that's called an aldehyde. If you have a carbonyl bonded to two carbon groups, that's called a ketone. That distinction is somewhat subtle, but it does lead to slightly different reactivity. If you have a carbonyl bonded to an OH group, that's a carboxylic acid. If you have it bonded to an O that's in turn bonded to a carbon group rather than an OH, that's an ester. That distinction might look even more arbitrary, but it's actually not at all arbitrary, and we'll see why, just not right now. Carbonyl bonded to a chlorine is called an acid chloride. And then a carbonyl bonded to a nitrogen. And that nitrogen could be with two hydrogens, or it could be a hydrogen and a carbon group, or it could be two carbon groups. Any of that would amount to an amide. So the important part of the amide is the carbonyl and the nitrogen. Alkyl halide is a carbon group attached to a halogen. It could be fluorine, chlorine, bromine, iodine. And then finally, an ether is when you have an oxygen bonded to two carbon-containing groups. So yes, I know this is a little boring. There are other functional groups. I would say these are sort of like the pretty classic ones. If we approach a functional group that we haven't defined yet, I'll definitely explain what that is. But one last thing I want to do before, fine, it's 11:50. Okay, we'll stop. Have a good weekend.